Hello friends, thanks for tuning in to Mobile Development with Xamarin. Today we have a jam-packed session as I'm going to go over how to create 100% native Windows apps, iOS apps, and Android apps using C# and .NET. That's right, you can create iOS and Android apps with C# and the .NET framework. So let's get right into it. So who am I and why am I so excited to be talking about Xamarin? My name is Matt Sokup and I'm a Senior Cloud Developer Advocate here at Microsoft. So that means my job is to talk about spreading the goodness of integrating Azure with Xamarin. I'm the face of the Xamarin community within Microsoft and also the face of the Microsoft within the Xamarin community. So how can you find me everywhere on the internet? Well, my name is CodeMill Matt. You can find me on Twitter at CodeMillMatt, on my blog at codemillmatt.com, and on GitHub at CodeMillMatt. So how did I get involved with developing in Xamarin? It was about 7 years ago now that I had to create an iOS application, and it was in an Objective-C and the iOS APIs. And I really wasn't sure how to learn both before I had to have the due date. And so after some searching on the internet, I found this thing called MonoTouch, and it promised to let me create an iOS app using C# and .NET. Well, I took a look into it, and it worked perfect. So I've been with it ever since, and I love talking about it. So here we go. First thing I want to let you know is that you can follow right along with all the slides and demos at this short link here, aka.ms/tsxamarin. I really encourage you to go out, as everything that you can do during this talk will be out there, from all the code to even all the tools that we're going to talk about. So please check out ts-xamarin. So what is native development? Before you heard me talk about 100% native Windows, iOS, and Android development. But what is native? Native can be a couple different things. The first and foremost is that you have native user interfaces. So when people go out and buy an Android phone or an iOS phone, they come to expect to have the native look and feel. They're buying the phone for a reason, and they want to feel at home within that phone. So you have all the native controls. You also want to have native API access. So if I'm making an iOS app, if it makes sense, I want to have access to the AirPlay API. So I want to be able to offer that to my users. And finally, you want to have native performance. We want our apps to run fast on the Android platform, or if we're doing an Android app, run fast on the iOS platform. So we want all three of these things: great UIs, great API access, and great performance. So how do we go about architecting these mobile native apps? Well, first way, you have the silo approach. And this is what you kind of think of in a traditional sense. You have iOS with iOS developers using Objective-C and Swift doing their Xcode. Android, completely different set of developers using Java and Android Studio. Then Windows with C# and Visual Studio. 3 different teams, 3 different languages, no shared code amongst them. They're trying to create more or less the same app, but it's totally different. Then you have the write once, run anywhere, where you use some HTML maybe with some JavaScript, you run it through an app generator, and out pops an app. The problem is that you have limited native API access. So you might not be able to get down to like the AirPlay until the app generator allows it. The performance is pretty slow, and the user experience, it might look like a website running within a web view. It doesn't look like a native application. This is where Xamarin's unique approach comes in, is that first off, Xamarin has wrapped 100% of each of the platform's native APIs in C#. So we can not only get at iOS's UI kit or core ML, we can get at them using wonderful C#. Same thing over on Android and Windows. Not only that, it's a shared C# code base. The logic behind all those, things like when we're calling out to a database or a REST service, are all done in one code base, and they can be shared across all 3 platforms. And you get a native high-performance app at the end of the day as well. So how does Xamarin work? So if we're building a Windows application, you would expect to have all the system.namespaces available to you. You would also expect to have all like the Microsoft.networking and the Windows.storage namespaces there as well. You'd expect that in a Windows app. Well, on an iOS app, you'd expect to, if you're developing, have MapKit, UIKit, iBeacon there as well. And that happens with Xamarin. So not only do you get 100% API access coverage, you also get all the system.frameworks there as well. So you can use system.link, you can use core graphics, you have the full .NET goodness when you're writing iOS applications. Android's the same deal. The full .NET framework, all the systems are there, and including the Android API coverage. Let's talk about user interface though. How does what I'm going to call traditional Xamarin do it? Well, we do still have that shared C# logic layer, but we still can create 3 native user interfaces. So we can create our apps natively using storyboards, the way that you would if you're using Xcode, using XML and Android Studio if you're doing Android apps, and using XAML over on Visual Studio for Windows apps. And code sharing. So even though we're creating our user interface 3 different times, our code sharing stats, because we're using our core app logic and it's shared across all 3 platforms, is pretty good. As you can see here, we're getting upwards of 70, 80% code sharing across all 3 platforms. So let's take a look at a demo of building a traditional Xamarin application. So we're going to slip on down to Visual Studio for Mac. All of my demos today are going to be happening on Visual Studio for Mac. They could just as easily be happening on Visual Studio on Windows, but I want to showcase the newness of Visual Studio over on the Mac side. So I have Visual Studio for Mac fired up, and the first thing I'm going to want to do is create New Project. Click that button, and then it comes up with different projects I can create. What I want to do for the first one is create a new Android app, and I'm going to create a blank Android app because we're going to start it from scratch. I'll click Next, and I'm going to give it a name. I'm going to call this one Dad Joke because what it's going to do is going to go out to a web API, and it's going to bring back corny dad jokes. You know, the type that when your dad tells them it kind of makes you cringe? And then we'll give it a project name and a solution name, and I am going to pop this onto my desktop to save it. And it's going to go ahead, go through and create everything. So then what we get after the template's created, we get something that's called main activity, which is going to host our UI, and then also a main.axml file. So when that launches, that's going to be an XML file where we can use to actually build our user interface with. And I am going to quick build it so we can get rid of everything here and make it clean, and we see the source behind it. You can see that it's just a linear layout. It looks like XML. It also comes with a visual designer, so I can drag and drop controls over onto this screen. So I'm going to just search for text view, grab it, and take it and drag it onto my screen. So if I look back here in the source, text view has been added. It's a control added to my screen. Back over in the designer, I have now properties. And you can see it has a name. I can change this text view's name to joke text. So that will allow me to access that text view by a name in my activity. I can change the text of it. I can say, no joke yet. And then when I back out, you can see it is updated here in the designer, no joke yet. I'm going to make sure my ellipsis size says none so I can have multiple lines to it. So this is all Android. It's exactly how to build an Android app. And I can even go into the XML and say android.textSize equals 24 dp, making it larger, and go back into Designer and see that it's bumped the size up. So I can not only go through the visual side with dragging and dropping controls and using the properties to change them, I can actually drop into the XML and do the same thing. Next, I'm going to add a button to the screen. Have that down there, and I'm going to change the name of the button to Get Joke and the text to be Get Joke as well. So now we have a rudimentary application that just says no joke yet and get joke. So now I'm going to go back into my main activity, and we can see here that we have set content view. So what this is going to do is that it's going to load up the XML that we just created and display that on the screen. So now I'm going to try and get the button and the text view into variables. So I'm just going to say joke text equals find view by ID, say it's a text view, and then resource.id.jokeText. So that's combining some Android find view by ID with some .NET, the text view generic and the var. Same thing with the button. Var get joke equals find view by ID. This time button resource.id.joke get joke. Great. Now I have access to my joke button and my joke text. So next thing I want to do is actually handle a click event on the joke button. So I can say get joke dot click, and then I can say plus equals async. Again, we're using async and await some .NET goodness. Sender E. So now I have a built-in event handler here. And so what I'm going to do next is copy in some text. And this is going to handle my joke for me. And it's going to go out and hit the web and get some jokes. But you'll notice one thing I'm using here. It's an HTTP client. Well, that's a NuGet package. So I can go out to NuGet, add packages, and this one happens to be system.net.http. And I have the full power of NuGet behind me. So I'll add that package in. And then while it's adding, it's going to ask me to accept the license terms. Of course, I'll accept that. And it goes through, and then I can correct my using statements. And now I have a fully set up quick handler using .NET in an anonymous method. So the next thing I want to show before I actually run it, so not only am I using right here .NET handlers, I can go in and I can specify that I want to use the native TLS 1.2 of grabbing out the SSL. So the latest and greatest. So I can do low-level Android stuff and also .NET stuff. Same project. Xamarin gives you the ability to go through and grab, pick and match exactly what you want to do to build your apps. So what I'm going to do here is run the app on an emulator. And while it's building and it's going to run, it's going to install everything on here. And here we go. It says dad joke. It says no joke yet. I hit it. It's going to run out to the internet. And it's going to bring me back a bunch of jokes. And it says ID, joke, status. It's JSON. But the problem here is that it's my logic where I'm getting the joke is right here, and it's, if I had an iOS app, it wouldn't be shareable at all. So what I want to do here is I want to make sure I want to refactor this. I want to make sure my logic is in a separate DLL so I can share it between an iOS app and an Android app. So what I'm going to do is open up a different app in which I already have an Android app, the same thing as I had before, where I'm calling out, doing everything within the click event, but I've also added an iOS app here. In addition to that iOS, I have a .NET Standard shared library. That library has a dependency, again, NuGet, on the system.net.http, also Newtonsoft JSON. And I have that Newtonsoft JSON in there because I'm going to change my dad joke that comes back into a real .NET object, ID, joke, and status. So the first thing I want to do is add a joke service into my core project. So I'm going to do new, add, new file. It's going to be a class, and I'm going to call it joke service. And it comes in here, and then I want to do a public, and it's going to be task. And you see, I can just double click there and then do dad joke. Again, we're doing .NET, so I can return tasks. I'm going to want to make sure this is async, and it's going to be get joke. And then from within that, I am just going to put in an implementation. So again, I want to make sure my usings are put in here. And get my joke URL in there as well. So again, what this is doing is the same thing as we hooked up before. Opening up the HTTP client, making sure our headers are set, and just doing a get string async. So it returns the joke as a fully formed dad joke object this time. So now I want to make sure I have the service working on Android and iOS so I can share the shared logic amongst the two platforms. So I'm going to go over to the Android activity and take out everything that I have in here and then just new up the joke service. So I'm going to say var joke service equals new joke service, and I'm going to say var joke equals await, because I can await for it, joke service dot get joke. So now I have my joke back. I can say joke text dot text equals joke, and the property I have it coming back to happens to be called joke. So I'm going to run it. It's going to build and deploy it over onto the Android emulator. And once it goes, I should be able to get my joke using a shared service. I hit it, it runs out, and then it comes back as right here. Wonderful. So let's move this over to an iOS app. So iOS, you build your UI through something called a storyboard, which I can do all the way over here within Xamarin Studio. As you can see, I can just drag and drop tools over to here. When I put my button on screen, I can give it a name, such as this one's called Get Joke, and the title is called Get Joke as well. Here I have a label. Again, I named it Joke Text, the same thing as I did over on Android. You don't have to name them the same, I just happen to do so. And so once you do that, there's going to be something called a view controller that backs this, just like the main activity that backed that. And so the Get Joke has on iOS, a different event that we want to handle. Here it's called Touch Up Inside. So it's a different API over on iOS, but we're still handling it with Xamarin. So I'm going to say Touch Up Inside, new async method. I'm going to new up my joke service, and I'm going to go ahead and grab it. So I'm going to turn on my iOS solution, debug, make sure I'm doing it right, and then I'm going to build and get it. So as it deploys, it comes through, says hello jokes, I click it, and here it comes. So there it is. I'm now using a shared logic layer with both my iOS and Android apps. So we're starting to realize the potential of developing with Xamarin. So as you can see, the code sharing stats with traditional Xamarin-based development is pretty good, but we can do better. Developers are always clamoring to do better. And that's where Xamarin Forms comes in. Xamarin Forms promises to have code sharing stats up to 90% of shared code. And that's because we can start sharing the UI layer. So what we had before is that we had the shared C# logic. And now we're putting in a shared UI code layer, a shared API that we can use to develop our code against. So previously, this is the traditional Xamarin route. Shared C# logic, you're doing your UIs separately. With Xamarin Forms, we now have an API that we can create UIs against. And so the way this works is that each platform has common elements. There's a button in iOS, there's a button in Android, and there's a concept of a button over on Windows. So Xamarin Forms takes that concept of a button and all the properties that that button would share, like text or click, amongst all three platforms, and makes it into an API within Xamarin Forms. We can now then program against that common API within our Xamarin Forms shared project layer. But not only that, we can still get at any platform-specific things that we want to. So if we really wanted to change our iOS application and really tweak it, we still could. So we get more code sharing, but we're still getting all native applications. So what's included with Xamarin Forms? Well, you have over 40 plus pages and layouts and controls to build from. And you can do it with XAML or code behind. You have two-way data binding. And so when you set this up, if something changes in a property in a C# code, in a C# model, it'll automatically update in the UI, and vice versa. If somebody's entering input in the UI, it's going to change that model in the background. Navigation. They've abstracted each platform's navigation framework, which is completely different across the platforms, into one within the shared UI code layer. There's an animation API. There's a dependency service, a messaging center. So here's a quick example of building a login page from shared code. We have tabs. We have entry boxes. We have a button. One, it looks completely different on each platform. It looks native. But the code that we're building it from looks all the same. So let's take a look at a demo. Xamarin Forms end-to-end. So back down in the Visual Studio, I am going to open up this app. And this app is a pretty intensive Xamarin Forms application. And I wanted to show it just to show what Xamarin Forms is all capable of doing. So I am going to run it first so you can see it. And we're going to be running it over on iOS. So as it spins up, and what this app does, I'm a cloud developer advocate, or as we like to call them, CDAs. And we travel a lot. I'm from Madison, Wisconsin, but right now I happen to be in Redmond, Washington recording this. So one of the things that we do with this app is that we're going to have it, so not only can I come in and see who CDAs are, but also which CDAs happen to be in Redmond so we can get together. But there's also another portion to it. There's a portion for other people who aren't CDAs to get in and read about the specialties of CDAs and to get a hold of them. And also the CDA visiting Redmond, maybe get them to go to your user group. So here's what the app looks like. It looks pretty good, right? You have these two little guys talking to each other, and it says, are you a CDA to log in, or do you want to continue as a guest? Well, let's continue as a guest here. So it's going to go out to the internet. It's actually hitting Cosmos DB, and it brings back all these people. So I'm going to click on somebody. We'll click on Burke here. And now we're seeing what Burke can all do, his skills, the projects that he worked on. Now, if we wanted to follow him, we can do that. And it brings up various Facebook or LinkedIn and Twitter that we can follow him on. And then the nearby. I can find nearby CDAs. And these are all the CDAs that happen to be near Redmond right now. One thing is, though, I'm not in this list, but I'm in Redmond. So I want to change that. I'm going to change the Xamarin Forms app so I can log in and mark myself in Redmond. So let's do this. Here's what a Xamarin Forms app looks like. When you new it up, you're going to get 3 projects. You're going to get an iOS project, an Android project, and then the shared project. This is a Xamarin Forms project. It's not unlike that shared core project that we were looking at before in the traditional based world. So within that shared code project, there's a couple different things. There's views, where we have different pages, which we set up our UIs. View models, which you can think of as the logic behind those pages. There's also other things such as effects and controls and cells, like little table view cells that we can change the UI of. But we're going to look at the views and the view models right now. So on the view, the page itself looks like this, where I have a content page, and within that content page I have a grid. So a grid, as you can imagine, is setting a layout in 2 dimensions. And then I can say how many rows I want in that grid. I can say how many columns. In this one, I'm just going to go down 1. And here I have an image. That image happens to correspond to these 2 little guys sitting in the pool. And here's another cool thing about Visual Studio for Mac. I can preview my layout inside Visual Studio. So I can see what I'm doing it's like almost a real-time designer. I can see my image, my label, and there's one thing I want you to know of. In these 2 labels down here, I can see the current location and update message, and they're binding. So that view model, which I mentioned before, which is kind of like the brains behind this page, that whenever I change a current location property, that's going to update and change this label to be whatever the current location I change it in the code behind to be. Cool. So what I'm going to do then is walk through adding logic to this view model. And the reason I want to add it here is because I'm going to show you the true power of Xamarin Forms, is that we're going to go through not only just change the UI, but I'm going to hit some really device-specific things, such as the GPS, such as going out and talking to Cosmos DB, such as going out and making sure we're connected to the internet, and I can do it all from this shared project. So the first thing I want to do is bring this up, make it sit, and then copy the first piece of code in. So this first piece of code says I'm just going to check the connectivity. So this check connectivity async comes back to this piece of code. And there's this cross connectivity.current.isConnected. That's a plugin that somebody else wrote that actually plugs into each device. And each device has a completely different API to check whether it's on the internet or not. But somebody else wrote this so I can get at it from my shared project. So it's abstracted, and I can get at it from my Xamarin Forms project in the middle, so I don't have to worry about how it's implemented on iOS or Android. Then, next thing I'm going to do, assuming I'm connected to the internet, I'm going to log in. I'm going to call this authenticationservice.login. What that's going to do, it's going to use a library to actually call up to Microsoft's Active Directory to log me in. So only CDAs, Microsoft employees, are going to be able to log in using my credentials. Third thing is, now I'm going to start updating my UI. I'm going to change it to the update message, whatever message I have stored in this variable. Next, I'm going to go and get the current location. So I'm using this geolocation plugin, very similar to the connectivity plugin. So I'm going to say, all right, phone, tell me where you're currently located. And then once it finds out, it's going to update that current location's latitude and longitude. 5 is I'm now going to update the message saying, all right, I have your latitude, longitude, but now, using that same geolocation plugin, I'm going to try to find what city and state you're in using that latitude and longitude. And once I find it, assuming that I can, I'm going to update the current location label saying, all right, now I'm in Redmond, Washington, and then the overall update message of where we are in the progress here. And then finally, I'm going to go out and use a data service and call it the Cosmos DB. And then put in the position, the address, and this access token, which I've gotten back from the authentication service to say that Matt is now just checked into Redmond, Washington. So now that I have that all put together, I'm going to run this over on Android on a real device. The real device beginning so I can actually hook up and hit the GPS for real. And we'll see it build and deploy here. In a couple seconds, it should pop right up. Building, building, building. Sometimes when it builds to a device, it takes a little bit longer than into an emulator, especially the first time you do it. So here we go, we're building, and now we're deploying to it. And there we go, we're installing it, and we are almost there. We should be running in just a matter of seconds. Okay, so we got the two guys talking to each other, and now we can see everything. This is Android. It's different than iOS, but the app itself works exactly the same as before. So I can go in, I can view Christina's profile. I can see if I should follow her or not, and you can see that this is the Android version of it. It doesn't look like iOS's version of the pop-up. It's different. It's obeying the native app. So I can go in and see, well, who's nearby? It's going to go out and hit the Android GPS. So next thing I want to do, I'm not in there, I want to check in. I'm going to hit this little button up in the upper right-hand corner, and we can see this page that we were working with before. I'm going to sync my current location, and it's going, you see Redmond, syncing with the cloud. So it's updating really fast, and those are the two labels that we're talking about updating. So location has been synced and updated. I'm going to go back, I'm going to find nearby CDAs, and there I am. So now I am checked in Foursquare for CDAs into the Redmond, Washington area. That's pretty great. That's pretty slick. And the amount of code here to go in and do all of that work, Cosmos, geolocation, checking the connectivity of the device, not a lot of code to do all of that. So there's also something called Xamarin Live Player. So this is fairly new, and it's a way that you can continuously deploy and debug apps. So the way this works is you can take a device or even a simulator, you scan a code, and then the app continuously deploys to your device without you having to go through the whole build and debug cycle. So here's a quick video of it running. You can deploy it, and then you start changing some XAML, and you can see that it changes like the color instantly on the screen. And you're not going through the whole build and debug cycle and having to wait for it to go to the device. That's pretty awesome. So let's see it on work. And I'm going to do it so it's not going to the device itself, but rather having it run on a simulator. So what I have here is Quick App. And this one's going to be fairly simple. I have 4 buttons on the app, and we're going to show off Xamarin Forms animation. One says translation, scale, rotate, and fade. So I have not only this preview button, which I'll hide the preview, but live run. So I'm going to live run it, and so that's going to deploy the app in the live player running on my iOS simulator. And I'll bring that up, and now we can see it. That was the only deploy I'm going to have to do. So I can take the scale button, and I can say text, and I'll move this over real quick. I can say text, scale, me. And it goes out and says scale me. That's pretty neat. I can say rotate it. And without having to even click save, the changes show up. So I can see how it's going to work on device. So you see when I'm clicking to scale me, nothing happens. So not only does the XAML work, I can go into my code behind, and I'll uncomment some code here. And then I hit scale me, and it works. It works without having to deploy to device and have to go through that whole cycle, and which sometimes takes a little bit. And that's really, really neat. So my files, they're not even saved. So it really speeds up the development time. And that's Live Player. The next thing I want to talk about is embedding. So Xamarin Forms has a reputation, an older reputation of being a little dry and for prototyping. And so a lot of people have gone with the traditional Xamarin route. But now you can bring Xamarin Forms in to your traditional Xamarin application. So no longer do you have to go one or the other. You can start bringing Xamarin Forms into your traditional application. It works with content pages. It has full support for the dependency service and messaging center. So let's take a look at how that's going to work. I am going to open up an app. So this is back to the Hello Jokes app. And it's exactly where we left it before, where we have the joke service, and we have a main activity that just calls out to the joke service, and that's all it does. Right? It looks exactly the same as before. What I want to do is I want to add a better looking landing page. I want to add something from Xamarin Forms into it. And so I can do that by having this Xamarin Forms page in my shared project, the same project where I have my joke service. And so it's going to look a little bit like this, the two guys talking, and then I'll have a button that says Get Joke. And it's called landingpage.xaml. So to put it in the main activity of Android, all I need to do is this. I can say var landing fragment, just give it a name as a variable, equals new landing page, which is just the name of the class, and then create fragment, sending in the current activity. And then to actually get it onto the screen, I'm just saying resource.id.fragment frame layout landing fragment main. So what I'm going to do is I'm going to replace the old layout of that we had running in Android with this brand new layout. And all the logic of that brand new layout is happening within Xamarin Forms. So I'm going to make sure my Android project is up and running. I'm going to start it up again. And as we're deploying, the same thing can happen over on iOS. iOS uses view controllers instead of fragments. And so you see here, I have a touch-up inside when I got to start things off with. So what I'll do, instead of going on to get the joke service, I'm going to push a new joke onto the stack. So in order to do that, I'm just going to do var landing controller equals new landing page dot create view controller. And then, so instead of having the new view controller show itself, I want to actually push it onto the stack, like it'll slide in from the over on the right hand side. And so I can do that with navigation controller, that push controller, landing controller, then true to say I want it to be animated. All right, so let's take a look at it over on Android. So you can see, instead of seeing that old layout, I'm seeing a brand new one. This is Xamarin Forms inside the traditional Android application. I hit Get Joke, and goes out to the internet, and it says, here it comes. New joke to it. Go over to iOS and say, I want to run on a simulator. I'm going to run on iPhone X, and it's going to be a little bit different because I'm going to push it onto the stack, the navigation stack, instead of just showing it by default in the beginning. And here we go, Hello Jokes. I hit it, and you see it came sliding over, but it's the same deal. It comes back. So now I've integrated Xamarin Forms. I've embedded it into a traditional Xamarin-based app. So Xamarin goes beyond just being able to get at native UIs and shared code. We also have native performance. Xamarin runs natively on iOS. It does full ahead of time compiling. You have producing an ARM to set up the Apple's App Store. It looks, as far as everything is concerned, exactly like you're doing it with Xcode. Over on Android, it takes advantage of just-in-time compiling, runs side by side, and it works just like it does. It's always up to date. We have same-day support for all the versions of iOS running back to iOS 5. When Apple releases it, Xamarin has it. And if it runs on an Apple device, Xamarin runs on it. If Android's running on it, Xamarin's running on it. Awesome. And the Xamarin platform is included in Visual Studio, and it's there in Community Edition. So not only Visual Studio, but as we were demoing today, Visual Studio for Mac. So Visual Studio for Mac, you can do .NET development with it, .NET Core, ASP.NET Core, Docker. There's tools for Azure, Azure Functions, Unity development. It's full-featured. And it's included with your Visual Studio subscription at no additional cost. And there's a free Community Edition. Of course, it's available right now, today. And it's fully featured. It's powered by Roslyn, just like Visual Studio on Windows. It has powerful refactoring. I really encourage you to give it a try. And Xamarin is open source, even Xamarin Forms. So you can go out there, and I would highly encourage you to do this, and see how things are built with Xamarin Forms, how the code is structured, and it's a great learning opportunity. And if you find that Forms isn't working for you, you can even raise issues, and you can see how the team is working on your issues, and you could even put in pull requests, fix the code as you want it, and bring it back in over. Xamarin is part of the .NET Standard ecosystem, meaning it adheres to the .NET Standards library. Same thing as the .NET Framework and .NET Core. So it is part of the future of .NET. So anything you can do in Objective-C, Swift, or Java can be done in C# and Xamarin. And again, please go out to aka.ms/tss-xamarin, and you'll have all the code, all the slides, and step-by-step instructions to work through all the demos that you saw today. It's a great step. It'll get you up and learning Xamarin, up and running really quick, and I really hope that you go out and do it. So again, thanks for tuning in to Mobile Development with Xamarin. My name is Matt Sokup. Please follow me if you have any questions at all at CodeMail Matt. My direct messages are always open, and thank you very much.